Hello and welcome to the 7th episode in our series where we create a 3D rendering engine from scratch. In this episode we will be adding CPU, multi-core and multi-threading support to our 3D rendering engine so that it can render each frame a lot quicker. Our end goal is to make a program that looks something like this. So I can look around and move around the map, and this program will take an object file and a texture file and render something that looks like this. So in the last episode we fixed some bugs and created this bit of code which splits and creates new triangles that are along the neoplane. And in this episode we are adding support for multi-cores. So we're going to write int CPU processors equals 1. So by default, if multi-core is set to false, or if there's only one CPU core, we just default to 1. And then down here, before we write the next line, we need to create a new variable at the top here. So we're going to write public bool multicore equals true by default. You can change it to false. And then down here we'll write if multicore CPU processors equals environment dot processor count, and then this is just going to set this CPU cores amount to the amount of cores the computer actually has if multi-core is enabled. And then we're gonna make this an array, and we're gonna write here CPU processors. And the reason why we do this is because we want to have multiple lists, and we're going to have as many lists as we do CPU cores so that we can divide the triangles among each list. So now we're going to write for x is int x is equal to, which we'll do I is equal to 0, I is less than CPU processors, add 1 to I, and then in here we're going to write temp triangles I equals new list, and then just this with brackets at the end. And what this is going to do is this is going to go for every CPU core. It's going to create a new list of the same type so that we can then divide it among the triangles. And so we're going to write if multi-core is enabled, then run this code, and we're going to copy this and paste it inside here. Up here we're going to write int core count equals 0, and then we're going to put square brackets and put core count in here, and then underneath here we're going to write core count equals bracket core count plus 1 percentage bracket CPU processors minus 1. And what this is going to do is we're creating a new integer, and we're going over every triangle and every mesh, and we're adding it to one of the lists, so the first list, and then we're adding 1 to this count, and then we're going to that core, so we're going up. But once we reach our CPU processors, so say we have 8 cores and we've reached the end of our 8 cores, we're then going to go back to 0. So then the first core again. This will evenly divide all of the triangles among all of the cores. But if we don't have multi-core enabled, then we can just write else brackets and then do this, and over here we'll put square brackets 0 because we're going to put all the triangles in the only core, the first core. And that's for this code. So over here we're going to write parallel.for brackets 0 CPU processes I, and then in here we'll just delete this and we'll go down to the bottom of this, and over here we'll just write swirly bracket semicolon. And so what this is going to do is this is going to essentially divide and divide the tasks among all of our CPU cores. So if we have 8 CPU cores, it's going to run this code, like split it among the 8 cores. And then in this code, what we're going to need to do is we're going to need to put square brackets I, like this, because it's going to go CPU core 1, and we're going to run all the triangles for CPU core 1, and then CPU core 2, and all the triangles for CPU core 2. And it's important to know that it's all happening at the same time. It's happening in parallel, which is why it's so useful and so powerful. So we're going to go along here, and before all of the T's, we're going to put square bracket I. And this is just what, from up here, what CPU core we're doing, and then what triangle we're doing. So we're going to do that for each one of these. Make sure we only have one square bracket. Yeah, we're going to do this for each one of these, like this. And that's it. So we're going along all of these, and we're getting our temporary triangles, the CPU core that we're working on, and then the triangles in that CPU core. So before we test it, there's one thing that we need to fix, and that's this over here. Now the problem that we have currently is, before, when we were rendering with one core, so all the triangles were done in order, and this ran fine. But now that we're doing triangles at the same time, so multiple triangles being drawn at the same time, this code is being used at the same time. And one thing that we are using is e.graphics. And this causes problems because we can't actually use this at the same time. But we can actually just delete this, and delete this from here as well. We actually never use it. So that is another bug that we have just fixed. And this will allow our program to then run the triangles all at the same time without getting any errors. So we give this a run. There's the car, and you won't notice much of a difference from just this little car, because it has very little triangles. It was pretty quick before with one core anyways, but when we do get larger scenes, such as the racing scene or game maps with thousands of triangles, using one core can be quite slow, getting down to about 2 to 3 frames per second. And so what we've just added is we've just added a major improvement to performance when we do get larger objects and more complicated scenes. So that's it for this episode. We've added multi-core support, and we've also added the option to turn it off. In the next episode, we'll probably be going on to now creating much better objects in Blender and learning how to bake textures and export our objects as OBJ files, and also triangulate our meshes.